Hello everyone, hope you are well. Today I am discussing OSPF features from the CCNP version 7 chapter 2 topic. Open Shortest Path First is a very feature-rich protocol. Let's discuss its features. OSPF, being a linked state routing protocol, was developed by the Internet Engineering Task Force IETF to overcome the limitations of distance vector routing protocols. Now let's look at what are the limitations of distance vector routing protocol have got. Slower to converge than linked state routing protocol. It is at risk from the count to infinity problem. The count to infinity problem happens when a router is unable to reach an adjoining network. A second router, one hop away from the first router, thinks that the unreachable network is 2 hops away. Meanwhile, the first router then updates its records to say it is 3 hops away from the unreachable network based on the fact it is 1 hop from the second router, which says it is 2 hops from the unreachable network. The routers continue incrementing their hop count until the maximum 15 infinity is reached. There are 3 methods of preventing this problem: split horizon with poison reverse, and triggered updates. The other problem continues with distance vector routing protocols are it creates a more traffic than linked state, since a hop count change must be propagated to all routers and processed on each router. Hop count updates takes place on a periodic basis in distance vector's case, even if there are no changes in the network topology, so bandwidth wasting broadcasts still occur. For large networks, distance vector routing results in large routing tables than linked state, since each router must know about all other routers. This can also lead to congestion on one links. RIP announces host or default routes by default. OSPF is a vendor neutral routing protocol. Any vendor's router can be configured with OSPF. Preparing for future, consider your company would migrate to MPLS VPN in future. There is no better routing protocol than OSPF to achieve this. Convergence is the state of a set of routers that have the same topological information about the internetwork in which they operate. OSPF achieves fast convergence. However, EIGRP can converge faster than OSPF because of feasible successor in topology database. OSPF forces you to design in a way which guarantees better stability and more granular troubleshooting if something breaks. OSPF implementation and troubleshooting in a large networks can at times be challenging. Both BGP and RIP are application layer protocols using TCP 179, UDP 520 respectively for communication. OSPF and EIGRP are network layer protocols using protocol number 89 and 88 respectively for communication. When an OSPF router first discovers a new neighbor, it sends a full update with all known link state information. All routers within an OSPF area must have identical and synchronous link state information in their OSPF link state databases. When an OSPF network is in a converged state and a new link comes up or link becomes unavailable, an OSPF router sends only a partial update to all its neighbors. This update will then be flooded to all OSPF routers within an area. OSPF uses a metric that is based on the cumulative cost of all outgoing interfaces from source to destination. The interface cost is inversely proportional to the interface bandwidth and can be also set. OSPF uses multicast and unicast rather than broadcast for sending messages. The IPv4 multicast address used for OSPF are 224.0.0.5 to send information to all OSPF routers and 224.0.0.6 to send information to DR/BDR routers. The IPv6 multicast address are FF02::5 or all OSPF version 3 routers and FF02::6 for all DR/BDR routers. If the underlying network doesn't have broadcast capabilities, you must establish OSPF neighbor relationships using a unicast address. For IPv6, this address will be link local IPv6 address. OSPF is a classless routing protocol. It supports variable length subnet masking (VLSM) and discontinuous networks. It carries subnet mask information in the routing updates. OSPF doesn't know the concept of auto-summarization. You can manually summarize OSPF inter-area routes at the area border router area. You have the possibility to summarize the OSPF external routes at the autonomous system boundary router ASBR. Clear text, MD5 and SHA authentication algorithm. The MD5 hashing algorithm is a one-way cryptography function that accepts a message of any length as input and returns as output a fixed length digest value to be used for authenticating the original message. It has been found to suffer from extensive vulnerabilities. Whereas secure hash algorithm SHA is a hashing algorithm. It is used for password and other important information hashing. SHA is used to create digital signatures of the data. By running the algorithm on the data, we produce the hash value, also known as the signature. The MD5 or message digest algorithm is widely used for cryptographic hash function that produces 128-bit or 16-byte hash value. MD5 generates 128-bit hash. To make it more secure, use SSA algorithm which generates hashes from 168-bit to 512-bit long. Although the slower than MD5, this large digest size makes it stronger against brute force attacks. If MD5 is broken, you can generate collision, so MD5 should not be used for any security application. SSA is not known to be broken and is believed to be secure. Thanks for watching.